Hello. Today we're going to study the very first lesson of our geometry. Uh, so when we start something, the first thing we need to understand is something we call definition. Now, it doesn't matter what we are what we are studying or what we are talking about. We first need to define it, define the terms we are using. Now, sometimes everybody understand that is because we already know the definition of certain things. Like say, I have a cat, then I don't have to define a cat. I don't have to say what is a cat. But if I just say this, I say I saw a tank, then we need have some kind of definition because tank could be means a container that with water and then the fish can live in, just one type of tank. But it could also be a military vehicle that we use during the battles. So we have to give a definition. Then we can talk about it. And most that in any study, you will see this. You will see there's a definition part of it. So basically, this says what are we talking about? The terms we have to define. Because sometimes the term we use in our study could have different meaning from the same word that used in everyday life. Just like we talk about a tank, could be something that we can put fish in, or something that people, soldiers actually will get into and use that in battle. And then the other things we need to understand is a property or properties. So you're going to see those two things. One is definitions, which tell us what is the object that we are studying, and the other is the property of that object. So if I talk about a tank for fish, so the definition is a container that has water that the fish can live in. And its property then would be how big is the container, what is the shape, and what is the material. Are we using, normally we're just using glasses. Well, can we use different container? Maybe a ceramic. There's nothing to stop us, except that it's very hard to watch the fish inside. So you're going to see those two terms a lot: definitions, properties. Okay, especially when we study in geometry, we like triangle. We have a definition. Definition is that we got three sides that is closed, figure with three straight lines. So that's definition of triangle. But the property of that, one thing we know that all the angles add together is 180. That's a property. And another one is if we got A, B, C, then any two sides, say A plus B, has to be bigger than C. Otherwise, you won't make a closed triangle. So those are the properties. So we got to be really separate them when we're trying to study anything. Is that what is its definition? What is its properties? Okay, so now we're going to, because we're going to talk about in geometry, we're talking about shapes. So we have to start from the very fundamental. So what makes a shape? Well, what makes shape? Well, we see that our lines makes a shape. Well, what makes a lines? And then we'll say, okay, points. Well, line can make the points. So if we put points together, and if they're just like they are infinitely close to each other, then we get the points and we get the line. Actually, if you look at the line in the line I draw, if you can zoom it out, and you'll see actually made the points, because the display we're using is it made of pixels. Each pixels is a discrete unit. So if you zoom in any picture, you'll see that it made of just points. But in terms of our geometry here, our definition that the lines actually are made of points that they are just pretty much so close together that there's no gap between them. Okay, then we have to say what is a point. A point, the definition is very interesting, but also show us in order to study something, we have to make things as simple as possible. So a point, the definition is a point has no size. Well, so there's no length, no width. Those are no width, no thickness. So based on the definition, actually we shouldn't be able to see a point because it has no size. There's no length, no width, no thickness. So, but we have to present it, and so we have to use a dot. But just means that the size really doesn't matter. If I write like this, or like that, or maybe different color, we just mean the same thing. It means a point. And so the point actually just tell us the location. So that's what it does. A point has no size. It just shows us a location. So we actually, in algebra, we learned the Cartesian coordinate system. Say this is a 1 and this is a 1. So 1, 1, it shows us a point. This point, just the location. There is no size to that point. But in reality, when we have to graphing something, we'll have to have some size. But just know that the ideal shape of a point has no size. So that's the first thing we're going to have. Well, once we define the point, then the next thing we're going to do is to define a line. Okay, so a line, the way we nowadays, the way we define line, we actually assume that is a straight line. Okay, in old textbooks, a line may not be a straight line. There could be like something like that. They also call a line. Okay, but in this book, the line is a straight line, which has just one dimension, and it can extend it on both sides forever. So we talk about something infinity. Okay, that's what we're going to deal with in actual algebra. We have to deal with infinity, then geometry dealing with infinity, and someday when you start to learn calculus, that basically that's what calculus does, is to deal with infinity. So a line is a straight line, so that's that, and it can extend infinity on both directions, and it has no thickness, which means we actually won't be able to see it because there is no thickness. Just like but we have to represent a line, so we have to draw the line. No matter what line we draw, the line has thickness. But just know that this is not the ideal case. Just like the point has no size, line has no thickness. Well, and no width. Okay, so all it does is a length. So you can actually get part of it, and you can measure from here to here. So it has a length to it. Okay, so that's we got a point, a line, and then the next definition is a line segment. I already kind of showed you here. A line segment, you can just it actually just has a beginning and end. For a line, there is no beginning, there is no end. This can go on both sides forever. So, but a line segment, it has a big starting point and ending point. So therefore, we can measure between those 2 points and the distance between that, and that's called the length of the line segment. Okay, and so we have that. Then there is something called a ray. Well, ray, normally we think about, we got the sun and sun rays going that. And now you can see that a ray has a starting point, but no ending point. So that's a definition in geometry, is that a ray is a line, is a straight line. But it has the starting point, has no ending point. Okay, so therefore the way we actually represent a ray, we have to go back a little bit early on. How do we referring to a line? Because there could be several lines. So the way we're referring to is pick up 2 points, we put a letter to it, and we call that AB. A line we write like this. There's arrow on both sides. That means there's no beginning, there's no end. And then we have line segment. The way we do that is AB, and then we put a bar over. So there is beginning and there is end. So that's we use this to represent line segment. And this as a line. Now for point, we just use a letter. Say A, we say A, a point. Okay, some say, okay, that's the point, because we could have different several points in a figure, so we had to specify it. Now on the array, we always pick a starting point that says this is N. Another point could be anywhere, so we write as AB and put one directional arrow to indicating ray. So that's our ray. Yeah, so we did point, line segment, and ray. Okay, now we're going to looking at a very important elements. We're talking about building blocks, points, lines, ray. They are building blocks of geometry. A very important building block geometry is called angle. So the angle is actually made of 2 rays. We have the starting point, and this side go that. And whatever we could say the tilt from, you can imagine we start from here, then we move to here. Now this, we tilt how much we move from here to here. And once we got 2 rays, then what's in between that is called the angle. So this is the shape of the angle, kind of like a triangle without a side. And we have this is called common point, and we call that vertex. called the vertex of the angle. Now, vertex can be used in other situations, like if you have a graph like this is also called the vertex. But here, we're talking about the vertex of angle. So this is our vertex angle. And the way we actually do indicate right angle, there is 2 ways to do it. So this is our B and C. So we know there is the 2 rays, AB, go this, and AC. Now, the angle, we can either write as that. This is the symbol for angle. We call it angle A. Or we use 3 letters, BAC, to indicate BAC. That's the angle. Yeah. So that depends on the situation. If we just have one angle, we can just use 1 letter. But if we got a situation like this is our A, this is our B, this is our C, this is our D. Now, if we just say angle A, we really don't know, are we talking about this angle or this angle or even this angle? So that's where the 3 letters, well, we know for sure. So if you say BAC, this is B, this is AC, so we're talking about this angle. Now, if we want to talk about this angle, then that's angle BAD. So with 3 letters, we are able to specify angle very clearly. Okay, so talk about point, lines, line segment, ray, and angle. And then we're going to looking at, so we have a definition of angle. Then we're going to looking at the properties of angle. Now, property of the angle, of course, the first thing we want to know is how big is the angle? Is that 30 degrees, 40 degrees, 90 degrees? Well, in the past, we're talking about almost 2,000 years ago until about probably 300 years ago. Yep. The way we learn geometry is called Euclidean geometry. Now, this is it was by a very important mathematician, Euclid. He wrote a book called Elements. Elements is a big book, actually have 13 volumes. Now, in that, they give us almost all the theorems that we know today. Well, not just given, he actually proved it. So his big influence on us, especially on Western civilization. The Euclidean geometry used to be a required subject in education. So in the Euclid's time, he only actually got 2 tools. One is a straight edge. So straight edge is like a ruler, but no marker. So you cannot use to measure. And another one he got is a compass. And there is one end, and there's another. So you can draw a circle. Compass, you go now, then you put one leg here, then you just turn it, you got a circle. So basically you can draw a straight line and a circle, that's it. But you cannot really measuring it. You don't know how long that is. So they cannot really measure angle. Angle is a kind of, in practice, we need to know the angle, but when we study geometry, especially Euclidean geometry, we cannot measure angle. Okay, But again, this is when we're talking about Euclidean geometry, so that's within that context. Now today we have all kinds of tools we can use to measure angle. So, just kind of give you background, like why when we're talking about angles, we're only talking about we're talking about let's see, 1, 2, 3, really just 4 type of angles. Okay, so even though in Euclidean geometry we cannot measure the angle, but we can actually use a standard, and based on that we can say, are we bigger than this or smaller than this? So therefore, the way we have to construct something which is in Euclidean geometry is really just the straight edge, draws a straight line, and a circle. So what he does is he's able to draw 2 lines perpendicular to each other. So now, if you can do 2 lines perpendicular to each other, then this one has to be a 90 degrees. Back then, it's called right angle. The Euclid called that right angle. So you can actually construct it. Just use rulers and compass. So now, having that, then we can say, so we got right angle now. Yeah, nowadays we know it's 90 degrees. And we can say angle. If the angle is less than the right angle, then we call that acute angle. And so the angle is less than 90 degrees. And the angle is bigger than 90 degrees. We could call that obtuse angle. Okay. Then what happens if we just got the one line, the angle in this line, this is a point here, this other vertex. It's kind of like you can think this is a door and there's a hinge. You can turn like this way. We call it 180. Or maybe you can facing this way, then you turn back. So that's what we call 180 degree turn. That is called straight angle. Okay, so therefore for Euclid or the Euclidean geometry, we only have 4 different kind angles: right angle, acute angle, obtuse angle, and straight angle. Okay, now having that, then we can start to looking at relationships between angles. Okay. So what kind of relationships we have? Well, if we got 2 angles, let's say we have something like this, then we have something like that. This is, so we call this A, this is O, this is C, and this is B, and this is D, and this is O, and this is F. So basically we got 2 lines. One is AB and one is CD, and they intersect, cross each other at O. Then we draw a line out like that. So now we can see the angle AOC and angle COF. So this angle AOC and another angle COF, this angle. So those 2 had the same vertex and has a common side. This is a common side. And those kind of angles are called adjacent angle. So they are neighbors. So they are close to each other. They are called adjacent angle. And so therefore we know these two are adjacent, but we can see that angle COF and the angle FOB, they are adjacent angles. And angle BOD and angle DOA. So BOD, this angle, DOA, this angle, they are all adjacent angles. So they're close to each other. Okay, now we know, so we're talking about the relationship between angles. And then we're looking at, if we got just two lines here, I'm going to get rid of one line here. We just look at AB and CD. So in this case, we have something called vertical angles. And vertical also just means opposite. So that means this angle, so the red, this angle, and this angle. So they have the same vertex, but they are not adjacent. And they are made of this kind of, between the two straight lines. So we call angle AOC and angle DOB. We call them vertical angles. Yeah, so this lesson we just have a lot of definition of our terms. So that's the first thing we need to know. What are we talking about? And of course, we could have BOC, so this angle, and AOD. AOD, that's also vertical angles. All right. Then we're going to looking at what happens if two adjacent angles form a right angle. Okay, so early on we talked about adjacent angles. Now we're going to talking about special adjacent angles. So for example, if we got an angle like that, so this is our O, this is our A, this is our B. Then we have another ray here, this is our C. Now, if they are made of 90 degree here, that means the angle AOB add angle BOC, and that equal to 90 degrees. They are right angles. Then those two, we call them complementary angles. So we're talking about relationship between two angles. So that's they complement each other. Complementary angles. Okay. And we also have, if the two angles forming a straight angle, which is 180, O, A, B, and C. So AOB add COB is 180. Now, in this case, we call them supplementary angles. Supplementary. Yeah. Now, sometimes supplementary angles, and sometimes we may not remember which is complementary, which is supplementary. Now, there the easy way to remember is that, think about when you complement someone, that is the right thing to do. Well, so the complementary angle is a right angle. So complementary someone is the right thing to do. So complementary angle is right angle. So just use that kind of help you to remember. Okay, so we talk about that very simple definition: point, line, and ray, and line segment. We talk about angle. We talk about uh, four different kinds of angles, and then we talk about the uh, relationships between angles, the adjacent angles and complementary angles, supplementary angles, and also vertical angles. Okay, now we're going to looking at our first theorem. And of course, in geometry, there's a lot of theorems. And we're just looking at our first theorem. Okay, the first theorem we're looking at is called vertical angle theorem. Okay, now theorem just means it's something that is true. It's a statement. We call that a statement. We just say this is this, and if it's true, then that statement we call that theorem. Okay, so the vertical angle theorem says that when two straight lines intersect, so got two lines intersect, they'll form vertical angles. In this case, this angle and that angle, they are the vertical angles. And the theorem says that the vertical angles are equal. That means they have the same degree. If you want to measure it, the same degree measurement. So, or you can think about if we just fold the whole thing, if it's all line like that, you can just fold to the left to the right. You got perfectly fold. So this angle will be on top of this angle. So that's the famous vertical angle theorem, and that was got used a lot. Later on, you'll see. Well, how do we prove it? And if we use algebra, it makes things a lot easy. We talk the language algebra, make things a lot easy. So we're going to say, okay, let's say this angle is x, this angle is y, and this angle then we call that z. Well, one thing we know that angle x and angle z, that's basically on this line here. So x plus z, that 180. And also this line we have, that is z plus y equals 180. Well, we got two equations. Now, if we use the top minus the bottom, if you remember, this is called system of linear equations. That's what we learned in algebra. Okay. And so top minus bottom, while we're going, we see that z and z get canceled. We got x minus y equals 100. 80 minus 100 is 0. Well, if two numbers minus each other is 0, then these two numbers has to be equal. So that's how we can prove that the vertical angles are equal. And of course, in geometry, we call them congruent. And that's what you're going to see a lot, is congruent. Now, congruent is more than equal. Like normally equal, we're talking about in terms of numbers. Congruent means that geometric shapes, when you can put one on top of each other, they will get a perfect match. So we said earlier on, if we think about the whole thing as origami paper, And if we want to fold this side and to the other side, and you see this angle will perfectly on top of this angle, a perfect match. Okay, now we're going to see an example. All right, I'm going to share that. Okay, let me close this one and share screen. Okay. Where is that? Make sure I got that. Okay. So we're going to look at this example here. And we want to see what is COA, and AOE. Well, they have the common vertex and have a common side, so they are adjacent angles. Now, what is COF? So COF, C here, let me clear that. C here, COF, this angle. And EOD, EOD. Well, you can see that this is one straight line, this is another straight line. So the angle they form are called the vertical angles. So that's vertical angles. And by the vertical theorem, we know they are congruent. Okay, we're looking at COE, and EOD, EOD. Well, this angle we have the same vertex, and this angle to actually put together, they are adjacent angle because it has the same vertex and has a common side, but they form a straight angle. So you can see that this is a line here. So therefore, these two angles, COE and EOD, they are we call supplementary angles. Now, suppose COF, this angle, and FOB, and this angle, one is 40, one is 50, add together is 90. So these two angles makes a right angle. So together make a right angle. So again, this is those two angles are adjacent because they have a common vertex, they have a common side. So adjacent, but it doesn't make a 90-degree angles. So they have we give them special name that we call them complementary angles. So that's what we got there. Okay, very good. So that's what we have for today's lesson. And I'll see you soon, okay, for the next class. All right, bye.